So that's our exciting show. And let's kick it off with the Parker Solar Probe, just like we did with that beautiful introductory video. So what is the Parker Solar Probe? Well, it is a probe that is going to the sun. It's actually flying so close to the sun, it's entering the sun's atmosphere, that region we call the corona. So we've never done that before. Now, it doesn't really quite get this close. This is a picture that was done before the mission. I believe that's a Solar Dynamics Observatory picture in the background. So we're looking at probably X-rays there or some sort of high energy. Very dramatic, though. And indeed, here's the launch of the Parker Solar Probe. It was a dramatic event. Just kind of crazy the way those flames engulf that Delta 4
Solar Probe. A daring mission to shed
that is
light
normal,
on the
though.
mysteries of our
When the
closest
flames
star,
come up over the Delta
sun.
4 like that, that's completely normal when it does that. Now, the orbit it was sent into, you can see here why we're so excited about the results we're getting from the Parker Solar Probe. Previously, we've had orbiters like Bepi-Colombo and Solar Orbiter going into these orbits that are close, but Mercury's even closer. We also have things like Stereo A, Stereo B, looking from a distance at other directions, but those are out the distance of Earth. So really, to get close to the sun, we had to really fling the Parker Solar Probe down. Well, actually, you got to slow it down. You have to remove some of Earth's orbital velocity and let the probe fall into the sun. It's not so easy. It is harder to get down there in the sun than it is to go out to Mars or the outer planets, because we already have all that energy. Earth is moving. You have to remove that energy to fall down inwards towards the sun. Now, what's so cool about the Parker Solar Probe? Well, we want to know, let me run that animation together. There it goes. It's looping for us. It's so cool because the sun has these streamers coming off of it, this solar wind, and we didn't really understand completely the interactions. We wanted to know the details of what was happening. Well, we noticed these sort of S-shaped features with the Parker Solar Probe for the first time, and they were called switchbacks because the material is literally kind of switching directions and heading back outwards. It's the magnetic field of the sun driving these. We don't fully understand it, but it seems to be actually related all the way down to features we're seeing on the surface of the sun. It could be coming between the granules. So really interesting physics related to the sun that we're learning from the Parker Solar Probe. Now, the Parker Solar Probe itself has also flown by Venus a few times. A beautiful picture here, an animation showing what it might have looked like. Venus clouded completely. Human eyes wouldn't be able to see the surface ever, but the Parker Solar Probe actually has cameras that are capable of peering through those clouds, infrared cameras. So we're seeing the night glow, literally the glowing heat of Venus glowing in the infrared. And Aphrodite Terra is a feature that can be seen in radar images that you bounce off of there. So as it flew past Venus, it was able to see those really cool features on Venus, which I don't know if they were expecting that, but I certainly wasn't. I was pretty stunned when I saw this very cool image. Now, other things that it's done, it did just recently enter the sun's corona. Now, you might want to know, how do we know it entered the corona? Well, it has to do with the fact that outside the corona, material isn't being pushed at very high speeds. The corona sort of runs into the interstellar wind. The inner part of the corona, you have these very strong streamers. Outside, they slow down a little bit. So let's take a look here. We'll run a video and see if it makes any sense here, because the Parker Solar Probe streaming along in its orbit, it gets closer and closer, and it enters a region right there. Boom, now we're inside of it. Now we're in that region where the solar wind is streaming more, it's less turbulent, and you go outside into the region outside of there. So let's take a look here. Inside the corona, very high energy there. You see a certain signature. Outside the corona, the solar wind is pushing all that material outwards. You get an outward flow. Inside the corona, the magnetic fields are driving the interactions a little bit more. The material's connected to the sun. It's part of that atmosphere of the sun. The material inside can return back to the surface of the sun. It can fall back. Material on the outside is continuing on the way and becomes part of that solar wind that's leaving the surface of the sun. So Parker Solar Probe drifted into that region where it was sensing that material was coming out and then falling back in, and it's being driven by those streamers in the magnetic fields. Outside of it, the solar wind carries it away, and it just flows away from the sun completely. So following along. Now, what did it look like when it did that? It did get that data. We showed it to you in the middle of that movie, the actual data. Well, let's take a look here. You're seeing actual streamers of corona. Well, that was the Milky Way that went by there, by the way. Did you see that? They were seeing the Milky Way and those bright spots. If you're looking at those, there's some of the planets. I believe almost every planet was seen in here. If you Google this one and find this image, let me back it up and run that again because it's just too cool. I think that might have been Venus. Earth is in here. Jupiter's in here. But what's so cool are those streamers that are going by, not the little streaks. Those streaks are more particles that are hitting the detector. Cosmic rays basically are particles coming off the sun. It's the long wispy streaks we're seeing that's actually the corona, and you're seeing material being carried away from the sun. Now, inside that corona, that material is carried out with the magnetic field, comes back in and follows the field lines. Outside of that, it's gone. So we've crossed that boundary, which is pretty darn cool. And this was during encounters 8 and 9. You can see some information about the electric fields and the magnetic fields that are happening inside there. But what was unexpected was that particles were impacting the side of the Parker Solar Probe. So there was high energy particles around the sun, and we're getting impacts on the side. It's actually could be damaging. So interesting for future spacecraft, other craft that are going to go into high energy areas like being close to the sun. We need to protect them against this sort of stuff. Now, the Parker Solar Probe itself is doing these Venus flybys. October 16th, it just did one. Flew by Venus again. And it's not just doing these because they're fun. Patrick, why don't you tell us, why is the Parker Solar Probe flying past Venus, and what does it have to do about the future of the Parker Solar Probe?
Okay, sure. In fact, Venus plays an immense role in modifying the orbit of the Parker Solar Probe. On its 10th flyby of Venus, the distance where it gets close to the sun, known as the perigeo, shown by that red arrow, this closest point to the sun, was reduced from previously 6.5 million miles from the sun to a mere 5.3 million miles from the sun on this orbit 10, or perihelion 10. Just to take a look at where the Parker Solar Probe currently is after that close passage for perihelion 10, it is right now out just beyond the orbit of Venus, although Venus is away from the Parker Solar Probe at this point. So all the green lines there that you see are all the past orbits, and the future orbits are shown in red. A quick look at what's next for Parker Solar Probe. Oh, actually, this is actually a detail there. You can see these. I marked at P10, which is the perihelion point, and where Parker Solar Probe is. But the next diagram actually shows the maximum distance, which is at top there, away from the sun, and the minimum distance, which is when it's at its perihelion, close to the sun. And you can see on the left there, we started off with perihelion 1, where the Parker Solar Probe was within 13 million miles away from the sun. And now it's at perigeo, actually, sorry, I'm getting ahead of myself. At perihelion 10, it's 5.3 million miles away. So you can see there's actually a total of 24 orbits. On the 24th orbit, where it gets to P24, which is December of I think it's 2024, the Parker Solar Probe will be 4.3 million miles from the sun. At that point, it will be traveling almost 400,000 miles per hour as it zips past its closest point to the sun. This is just the timetable from last year. You can see there were some Venus flybys, which took it closer and closer to the sun. This year, there are 4 perihelion passages, but no Venus flybys. So the perihelion distance will be maintained at 5.3 million miles. And then, of course, we have next year, there is 1 Venus flyby. But there are actually a total of 4 more perihelion flybys for next year. So that's what we're looking forward to. And this will continue all the data gathering phases of Parker Solar Probe. Just to give you an idea of how big the sun would look from the vantage point of Parker Solar Probe, on the right there, that's the size of the sun. It's just about half a degree as seen in the sky, or roughly about the size of the full moon if you view it from Earth, of course, safely. But from when Parker Solar Probe is close to the sun is 28 times the diameter bigger from the vantage point of the Parker Solar Probe. So it's really up close and personal right next to the sun. This diagram just shows you that Parker Solar Probe is striving to get closer and closer to the sun to unravel some of the structure of the sun, the inner corona, the outer corona, why it's hot, and also to gather information on the dust environment around the sun. So more interesting results to come as the Parker Solar Probe journeys into the outer atmosphere and the inner atmosphere of the sun.
Yeah,
Right.
Absolutely. I can't wait for it to get closer and closer as it's going to do these next passages after that Venus flyby. We'll get a little closer. And then we'll just keep getting more data.